episode of building a Flutter game with basically it's supposed to be a 2D game, multiplayer. So for now, we basically just did a few things. We have these repos here. So Batufo is the working title of our game, and so far we added rotation and added a game. You can see here. Let me make that a little here. You can see how far we actually got with this. So we got a rotation going, and as you can see, this also works in the browser, which is kind of like an advanced, well, not an advanced, but it's like you need the latest version of Flutter to make this work. And what we'll keep doing is basically today we'll add some gestures first. So we'll add, I want to control how this rotates. And what we'll keep doing also is ensuring that this actually works in the browser as well. So we don't want to kind of give up on that idea. The idea is that if you keep it running in the browser, I can also publish specific every time we have an update, every time we improve something, we can basically push this on the website, and everyone who's watching or who's kind of interested can actually play with it. So that's the idea. Now another thing that I mentioned earlier is I already implemented I implemented this to a certain point, but I wasn't doing this from scratch. I was using the Flame framework, which again is a great framework. I just had numerous reasons why I wanted to do it without a framework. I wanted to do it from scratch. So that's what we're going to do, keep doing. So today, again, we wanted to add gestures. And as you know by now, if you have been watching, I use actually the previous implementation to sometimes, get inspired or remember how I did certain things. So what we'll do is we'll run this on Mac, and we also will launch a Chrome version of it. So we launch it on Mac first. We kind of want to see the output over here. And then we'll also launch a Chrome version. And if things work as I expect, as I hope they would work, every time we update, both running versions will actually automatically get updated. So here we have our rotating player, and now we'll do the same thing in Chrome. So we launch another one. So now we have two mains running. It's right now going to build for Chrome and syncs the files there. And okay, so now we have two games basically running. Right, one is running, so we cannot make this any smaller. So what we'll do, we'll just move this over here a little bit. Okay, so now what we can do, first of all, we don't want obviously to have the player spinning by itself. So here in the update, basically we update the angle, and I'm still not entirely sure how I want to do the update of the model. I think that will come clear once we implement this more. The main idea is that in order to have this multiplayer, we need to somehow communicate to a server what the current state is. So basically all the players have the same world, right? So if I shoot something in my let's say on my device, and someone is in the same level with me, then obviously they want to see also their shot. So we'll have to see how we do that. There are several strategies. Some of them are very complicated, mainly to avoid cheating. Like that people basically build themselves their own front end, so to speak, and then send the server all kind of things. So like for instance, I am now here, so I'm not shot or whatever, or increase their health or whatever. We are not too worried about this in this little game, so we might actually do a simple strategy. But we have to keep this in mind already. This is really early to think about this, but we have to keep this in mind because this kind of dictates how we keep our models, right? So for now, we're just going to, I'm returning a model here because I'm thinking that maybe we want to make them immutable and copy them. But if we actually serialize them to the server, we already create kind of a a snapshot of it anyway, so we might just actually update it in place, but we'll see about that. So for now, if I now save, we should update both of them and they should stop spinning. And you can see that this didn't work like I expected. Somehow it did not. I guess it's supposed to be, if we go here now and we save, okay, so now this one stops spinning. And you can see that it actually kept its state, right? It stopped spinning wherever it was. So it looks like we can have two running at the same time, but whenever we save, only one of them, whichever one we select over here, gets updated. But that's fine. So what we can do now is we need to add some way to rotate. So what I basically want to do first, I want to add keyboard support. So basically with the left arrow, the right arrow, or the A or D keys, right? If you want to do the kind of the WASD, like the Doom controls, I want to basically start rotating. So what we'll do is we create a new folder here, or package, and we call it inputs, right? And that's basically, there are two kind of inputs that we're going to have. One is a keyboard. That's if you play it in the browser or if you play it on a desktop, basically. And the other one will be used for phones. Obviously, like we can actually use gestures even in the Mac app. We can simulate gestures there, but the main idea is that you use a keyboard. So we create a class. We call it keyboard. Oh, one thing before before I go on. We can just get that far. Sorry. So what I want to point out is a schedule for today. As I kind of said in the in Twitter, this is going to be some sort of a marathon. So I'm planning to do. Okay, we'll have to turn it off. I'm planning to do multiple sessions today, and I outlined them here. So right now this is my time, Mountain Time, so this is 4:30 Eastern Standard, and then so we'll go until about almost 1 hour and a half, then have a short break, and then we'll do another hour, short break, have another hour, and then then it's dinner time, and then I'll do another session afterwards. So that's going to be 9 p.m. Eastern Time. But if you open this, I'm going to post this. Well, you're already on my channel, so you should see this. By the way, if you want to say hi and just let me know that my chat works, that would be nice. And also in the chat, I will post the code repo. So if anyone wants to kind of look at where we are, they can. And another thing that I actually wanted to do that I forgot almost is I wanted to tag. So we're going to tag the current state as episode 06, and we're going to say start. And so, or let's just do it like this, start. And what we want to do is we're going to keep doing these tags. So if you're watching this later on YouTube, I will put a link in where the code was at the start of the episode and where the code was at the end of the episode. So we push the tags up. Okay, so now we can start making some changes here. So we got the input, and basically what we're going to use is we're going to actually wrap the raw keyboard that Flutter provides us. So what we're going to do is we're going to create a game keyboard class, right? And in there, we are basically providing the pressed keys, and we'll get to this in a second how this actually works. So we're going to have an iterable game key, which we don't have yet, and then we call this pressed keys. So and when I'm doing this now, I'm going to explain a little bit why we're doing it this way. So first of all, let's create an enum game keys to get rid of the error. Okay. So now everything should be happy. Okay, so it's not happy because, so let's say left, right? And we actually going to, so for now we're going to do left and right. That's what we want to know. Did the player do left and right? And we don't say arrow left or A. For us, it's the same. It doesn't matter if the player pressed, the arrow key, or if you press A, it means left. So that's what we're concerned about. So then basically there's this raw keyword instance, part of Flutter. And basically it provides us a few things. It provides us with listeners. We can actually listen to key events, right? So we could get an event. But the thing is, we don't really need events, and we don't actually want events at all, because we already have a game loop. So what we actually want to do instead is we want to just basically, let me just make sure that my mic is working. Okay, good. We want to basically, in the game loop, we just want to check like what keys pressed. So we're coming around anyways, right? We don't need the events because we're already going in a loop, and we're going to keep checking. Did the player press a key? Is this key pressed? Do we need to update the player and so on, right? So what we'll do is there's this a set of physical key pressed. Now, like it's basically a set that means that no key is going to be in there twice. And then what we actually want to do is we want to somehow map this to the game key. So we say map, and then we do game key, and then some keys obviously are not mappable to a game key, right? If I press X or something, that's neither left or right. So then I basically need to say where X, right? I'm going to filter the ones out that are null, right? So okay, so now obviously it's complaining because I don't have this method yet. So let's create that. Okay, so let me do that again. It's the problem is that I'm using Vim bindings, and some things just don't really work very well. Okay, so we have the toGame key here. Now we get a physical keyboard key, and then basically what we're doing is we're checking what kind of key this is. So we say, for instance, if E is a physical keyboard key, and we say it's left, right? It's actually arrow left, right? Then we just return game key left. So now we basically map this, and obviously we want to say also if it happens to be A, right? Because that's a WASD. So we say if E equals physical dot A, and it's key A, then we return left, right? And then we do the same thing for right. So if it's the arrow right, or if it is the key D, right? And if you look at the keyboard, that's that would be basically the WASD thing, and then otherwise return null. Okay, so now we got this going on. Okay, so we need to obviously return this. Right, so cool. So we got that. And now what we need to do actually in our update loop in the game, we need to check if some key was pressed. Sorry, I just touched the keyboard. I hope to do not do that too much. So in the game, in our game loop, right, which is but full game, we need to basically figure out what games were pressed, right? What keys are pressed. So so the problem is I'm currently thinking of who's responsible for that. Is it the player, or is it something in here where then we rotate the player? So it's an interesting question, and I'm just looking up the way I did this there. So in the original version, I had the process key thing as part of the player, as part of the game. But I think since the player is the one that actually reacts to keys, but well, maybe what we should do is like multiple things can process keys, and they'll take them off the stack, or basically they remove them from that set. And so then, like only one gets to process a key. So whoever gets to process a key first wins, which I think makes sense. Because you don't want to do two things because a key was pressed, right? So if the player, for instance, wants to rotate, and then somehow we have something else registered to the same key, that's probably a bug anyways. So actually what we're going to do is we're going to go back to this keyboard here, and we want to actually create a set from this. It actually makes more sense to have a set of game keys. And it seems like it's happy, but I don't understand why, because this one should return as an iterable. Yeah. So what we want to do is set dot from iterable, right? That sounds more like it, right? So in order to just test this, what we'll do for now, we put just a little thing in the game. Number 2 for game here. We're gonna put we're gonna get the keyboard, right? The game keyboard. Then dot press keys. Dot. So we're gonna for final key in this, right? So we're gonna debug print the key. Okay, so that should actually work. So now if we save it, okay, and now we press left, nothing happened. Okay, interesting. So instead what we should do is probably, let's just do print all the keys, and then well, the thing is that sorry, I want to print this like this. Okay. Okay, so now it's printing nothing. Yeah, okay, it's printing that. Now if we press a key, nothing happens. Okay. Okay. So let's go back to our keyboard and see what's wrong here. Yeah, we get nothing back. It's not nice. That's not what we expected at all. So we get empty sets all the time, and I'm not entirely sure why that's happening. I don't think we need to initiate anything. Let me double check that there wasn't like some tricky thing that we had to do. I mean, we had our and the real thing, we had our game wrapped in a gesture detector, which may be needed in order for the key to work. So let's just wrap it with a gesture detector, just to be sure that that's not the problem. Okay, so good, nothing. Actually, what I'm going to do is I'm going to put a debug print as well in here. Maybe the mapping is just not right. Oh, there's a bug in there. Oh, we need to wrap this in a... Okay. So now let's see. Yeah, we're getting nothing at all. Oh well, first of all, we need to make sure we have that. Okay. Okay, so now... Okay, we're getting keys. Okay, good. Okay. So it's just our mapping that somehow is off. Okay. So that's actually good news. Let's just remove the gesture detector again, because that might not be needed after all. Let's see if we still get keys. Okay, we still get keys. So that had nothing to do with it. So here's the problem. We are mapping these keys wrong. Right? So why are we mapping those wrong? So it says key A, right? Clearly. And then we want to return game key left. Oh, that's not it. Okay. So what we'll do is let's just remove this debug print for now. Still get nothing. So that's really weird. I bet you if we remove this, we're gonna get a bunch of nulls. So let's do that. We should get a bunch of nulls. Okay, so we get nulls. Okay, so we're pressing our keys and we're getting nulls, and somehow that's because it's not recognizing the key, which is really, really odd. So basically we are not recognizing the key at all. So we're just going to print E. And we need to import this again. Could you? So, all right. Okay. So now, let's see. And then key A, and then it says null. Okay, physical keyboard key, it's A. Why is it not recognizing that? Oh, we have an AND here instead of an OR. Okay, so now this should all work. That's a little dumb little bug. Now we should actually, okay, now we're getting what we want. Okay, left and right. Okay, good. So that's working. We can remove our little log statement here. Okay, cool. So now once we move it, right, let's just save this again to get rid of all this logging. So as we move, we get left, we get right. So you can see that, right? So now basically what we'll do is we have all the keys. So what we'll do is when we update the player, we'll actually tell it what keys were pressed, or we could already normalize on the gestures. But maybe we'll let the player decide how to do that. So let's just do that. We're gonna say we have a set of game keys, right? And okay, what did we call this? Game key. All right. So now basically, if what we can now say if keys dot contains aim key dot left, right? Then we want to rotate left, and if it's right, then we want to rotate right. So let's just do that real quickly. Model dot rotation, or angle, we call it angle here, plus equals. So if it's left, we actually rotate to the left, right? So I explained yesterday actually that when we since we make our canvas 0, 0 based, this basically this here, right, is exactly 0. The angle of rotation is 0, and once we go up in the angle, we rotate this way. Wait, I didn't want to have an ellipse, but that's what I did. I may have to find a better tool, or maybe I'm just using it wrong. But basically, we wanted to rotate this way, and basically this would be pi, and this would be 2 pi. We were back at where we were. So what we'll do is we'll say, okay, we'll rotate by a certain number, right? And we add that to the game props. And actually we will put this in here. Well, actually, the player might just own that. I'm not too sure where to put all these constants. So if it's supposed to be in the player, or it's supposed to be, in some global game props. But for now, let's just hardcode the value. Let's just say we'll rotate it by 0.2. And since some of them you might say, well, why don't you take DT into account? That's because if you press the key one time, you want to have the certain amount of rotation, no matter of how slow this was. But maybe we'll play with it, and we'll see if maybe we need to take the time that passed since the last update into account or not. So now let's just try that. We'll try the left rotation for now. So here now I'm trying to do left rotate, but we're not passing this yet into the player. So we actually need to pass the keys. So I'll we want to get them once, and then you see here what we do when we are we are getting them once, and actually we may want to clear them, but it actually is only showing us the keys that are currently pressed at this moment. So this should actually be fine. So we do pressed keys here. Oh, actually it's the second argument. Pressed keys. Okay, so now we're rotating. Okay, so that's cool. Now you see that we're rotating. Oh, now actually we don't have to print these keys anymore. But we're rotating quite a bit. So what we actually want to do is, so for instance, if I hold it, rotate a little bit too much here. So let's play with this a little bit and say, let's make this 005, right? And see how that works. Okay, so now it's rotating very slowly, right? But then we say, okay, well, depending on how much time passed, maybe we want to increase that angle a little bit. So now let's see. So now we're rotating. This seems to be fine to me. Maybe now we can make this even a little slower and play with that. Okay, so maybe a little faster. You can see we're just fine-tuning this as we like. We can always change this later. And so now here's the question where this constant belongs, right? So first of all, I think we should pass this into the player. So we're going to make a required property here. Required. And the reason why I'm not just making an argument is because, you know, it's just a double, and there might be a lot of doubles. So I want to avoid that we confuse our these parameters somewhere. Rotation, let's say per key press. Okay, so we can always rename that later. So that's basically what our field will be. And so we say this dot rotation per key press. Okay, so now we need to pass it in. So we have that constant here, or it's actually a factor, right? Rotation factor. So let's just say key press rotation factor, right? Because it's a factor that we actually multiply with the time change, right? So now we need to add that to our game props. Right, so let's say static const, and if it's something, and I think it was 0.0.3, so we don't need to say it's a double because it's a const. So we can say I had some nice little naming pattern here. So keyboard, we can say key press. Let's name it keyboard rotation factor. And we actually call it player, so we know. So it has to do with the player. And so now, back to our player, we also rename this to keyboard. Okay. And then obviously from the game, we need to pass it in. It should give us, so here we go, it gives us a warning now. So keyboard rotation factor, that's what we want to pass in. And that's going to be the keyboard. I don't understand why it's not. Oh, it's because it's supposed to be the constructor, right? So, Keyboard rotation factor. Okay, fine. Trying to avoid to type, trying to make the UI, the IDE help me, but I think I'm overdoing it, and actually everything becomes slower. Okay, so now we got that, and now basically we need to do keyboard rotation factor. Okay, fine. And then when we, otherwise, if the key contains right, actually we don't need to have it. Otherwise, do we need anything else? I mean, if you're pressing both keys, that's kind of your own fault, right? So we'll do it this way, and why is it complaining? Key still contains, oh, missing parentheses. Okay, so now we're gonna say the angle, right? And then we say that if the angle is actually now gotten greater, or we have a function. So actually we're gonna make a function here. Increase, let's just say double increase angle, and we pass in the angle, right? And then we pass in the double d, the delta, and so basically do this here, the delta, right? And then basically what I wanted to do is actually we want to make a result. We don't want to reuse variables too much. Equals angle plus the delta, and now what I want to say, if the res, so basically what I want to do, if the res is greater than 2 pi, so we're gonna make a constant here, const I don't know, 2 pi, I don't know how else to name it, is 2 times pi. The reason why I don't want to, I probably would get optimized out, I suppose, but this is something we actually can calculate at compile time, right? So we want to actually have that already here. 2 pi, when it's greater than 2 pi, return, so we want to return res minus 2 pi, because that's the same thing. So we just don't go like, for no reason, we like get really, really big angles, because once we reach 2 pi, right, once we back here, we basically can start over with 0, right? We just want to, we don't want to go that great. So, and then now we can basically say return, model.angle equals increase angle, and we give it the model angle, and the right. So basically here we can actually pass it. So here we give it the delta, right? But actually what we can do, give it the dt. Actually not, because it needs to be negative sometimes and positive sometimes. So we do times the keyboard rotation factor, right? All right. Otherwise what we'll do is we increase the angle, but it's like minus dt, right? We need to be negative because we want to go to the right now. So that should work. Right, so okay, we got a problem here. To double was called on null. Okay, so we're not passing in the keyboard rotation factor correctly, it seems like. Huh. Maybe we need to just restart it for real. Okay, now it works. So basically we did kind of, sometimes you have to do a hot reload. So there are two ways here. We can do a, what's called a hot reload and a hot, like OBS crashed on me and or the internet was not working. So I think now we are actually back on. I hope so. It looks like it. So let's just hope that we are back on and everything's back to normal. Let me just refresh my page here, see if everything is back to normal. So yeah, we are back on for about a few seconds here. And it says it's excellent. So I don't know why OBS sometimes keeps crashing, but that's fine. So we basically just to, I don't know where we actually stopped streaming, but basically what we're doing, we are sending the player the keys that were pressed. So when it updates, it can then adjust the angle left and right. So this works in the browser and in the Mac OS app. So what we'll do is we actually will check that in. Keyboard rotating via keyboard input. Okay, so push that up, and now obviously the next step would be the thing is though that we might change this value. It's rotating very slow right now actually. So what I'm going to do is I'm going to make this a little faster. And now this restart in the browser. This also restart in the. I wonder if there's a way to say restart in all of them. I bet there is, that I just don't know. So this is actually a little better, a little faster. Somehow in the browser it's weird. Okay. Did we restart it here as well? Or maybe we have to do a hard reload to pick up the new static. Yeah. So that looks much better now. So that's the thing with these statics. So if you want to be able, I learned one thing. If you want to be able to change those better on the fly and not have to do a hard restart, you make this a getter. So every time it asks for it, it will get it, and then it updates in a, even if you just do a hard reload. Okay, but that's fine. So now let me actually just, there's no reason to have a, so what I'm just doing, I'm amending and I'm force pushing. Hoping that no one else got the code yet, which is very likely that no one got it because we're the only ones doing this. Okay, so we got the rotation. Now what we'll do, we want to move the player forward, and the way we'll do this is in the keyboard we'll have a top, or let's just say up. So then we copy this and we say if the arrow is up, or if we press the W key, then we'll say it's up. Okay. So then if we go back to our player, then we'll say, well, if the key, let me just copy that a little bit, key contains up, now basically what we need to actually do is accelerate. And we don't have any of this sort yet. Model. So what do we want to do? We actually want to set the velocity to something, right? But we don't have velocity yet. So I'm going to. So I did for these kind of things. I did a vector class before, and I'm not going to implement this by hand here, but I'm actually going to double check what the offset already gives us. We might actually not need a vector basically what we're trying to do is we're trying to figure out how can we show a speed, right? The velocity. How can we show it? And normally that's a vector, but technically an offset might also be used as a vector. So here we have the angle of top position. Where do we have an offset? Oh, I just offset. All right. So there's an offset here. So let's look at what this has. It has dx, dy. It has a distance. It has a distance squared. But what we also need, so that's direction, so that's good. So it has, let's see what it has. It's a distance, distance squared. That to me looks like what I called magnitude squared. Yeah, I called this magnitude squared in my and I'm looking over here. So basically, I'm looking at this vector class that I already implemented. We don't have to look at it unless we use it. So I'm just double checking here that this is everything I need. So there's an angle, but they call this direction. Direction is what the angle of this offset is radians, clockwise from the positive x-axis. So that's exactly what we call the angle, and also the way we calculate it is exactly the same. So we have that. So we had also an angle in degrees, but we might not actually need that. Then we had reverse, which is basically just scaling it with -1, -1. So we might not need reversed. Then we had normalized. So there's something that we might want normalized. But basically so normalized is not that much. It just basically divides every axis by the magnitude. And we have already the distance, which is the magnitude. And so we can easily add that if we want it as a separate function. Normalize. We don't need that this much. So as we can see here, Dart UI already gives us a bunch of cool things to work with. I'm actually now thinking that. So there's a rotate by that we have on the vector. I was thinking maybe we should make a vector and have it inherit from the offset. I mean, the rotate by just takes the angle and rotates by. So we can actually. So we have a rotate to function here, which is kind of yeah. So that's something that's actually kind of useful. I mean, the cool thing is if we actually inherit from offset, right? Then we can also pass it in anywhere where an offset is required. So that's kind of cool. So then we can easily interface with all the Canvas APIs, right? So maybe that's what we should do. So what we're going to do is we're going to make a new folder, and we call it physics. And in there, we're going to create a vector. And so so basically a vector will just be a class vector will just be an offset with some more things on it. Okay. So we're going to make a show here just to be 100%. So basically, we need to call super. Okay, so that's fine. And then basically what we want to do is we want to add a few things that we're going to get the, well, we're going to add them as we need to. So let's just say that. So now we have a vector. We use the vector wherever it makes sense for the velocity, and then we can add the functions that we need later. So let's just keep it that. Obviously, we could have used extension methods. I don't think it's a good idea because we are clearly the vector is for certain things. It's not going to be used for everything. So clearly we want maybe something different. So now we can go back to the player model, and we can say velocity. So we're not making it final because we are opting for now to change things in place and have some ideas about how we can change that later, how we can fix it. I might do setters and getters to control if a model is dirty or not. So then basically we need the velocity here, and then we're gonna also do this here angle. Okay, so that's another thing. Like we might override the toString method of a vector, but we'll see about that. So now we have a velocity. So what we actually want to do, first of all, we want to kind of think of what's going on. So when we press a key, we apply a force, right? So let's just define all these things in our game prop. So first of all, we're going to say what's the mass of the player, right? So we say player mass, right? And we're gonna, let's say we put this in, I don't know, 4.0, and it's whatever it is, kilograms, tons, whatever. It's kind of just, we don't have a unit there. It's kind of just for us to calculate things, and however we factor this in, like that will kind of decide what this actually means. So let's just say we have 400 kilograms of ship, light ship, and then basically the force that we apply is going to be the player thrust force. So if you move forward, right, we're going to put a force. And so if you look at what we're actually doing here is like F equals m times a, right? So it's the Newton law of motion, which means that the force is m times a, and then m times a, right? And so then if we want to calculate the acceleration, which is a, to our player, we basically take the the force divided by the mass, right? So if you say F equals m times a, then basically that means that a equals F divided by m, right? So let's just say the thrust force is 1000. Okay, so that would mean that every time we accelerate, we're taking the 1000 divided by 400. So our acceleration would be 2.5. Okay, and then we'll play with these numbers. Obviously, you know, maybe coming up with a realistic mass first, and then deciding what the thrust needs to be to move it makes sense. So 400 kilograms. Let's just say we think of kilograms here. 400 kilograms makes sense. Let's just make it 4,000. It's a heavy ship, right? 4,000 kilograms. By the way, for the American viewers, 4,000 kilograms is roughly a little more than 9,000 pounds, something like that. So, so then we have the thrust force, and so basically now when we apply an up key, we basically will increase the velocity by the. So let's move that down because it's private. And also, by the way, we have the random method here. So actually, I'm gonna have to talk about that in a second. Once we get this working, we might actually totally separate out this controller code, which is basically updated, controls the models, right? Controls what's happening in the game from the render code. And the reason is because we want to maybe later on move that to the server as well. So we can't have rendering in there. But okay, let's say increase velocity, right? So we give it the original, well, it's a vector, right? Vector velocity. And then we say, so the delta is always the same. So, right, there's no delta. Once we apply thrust, we apply thrust once. So, so what you can do is, so first of all, we would calculate the force. So we have the force. We calculate the acceleration. So, but it's basically the magnitude of the acceleration, or like what did they call it in the offset? In the offset, they called it something else. Offset. They called it distance. Kind of weird. I would say XL mag. Let's call it that. It's basically. So actually, that's a constant, right? So we actually calculate that here. Static const player acceleration. And which we call it thrust acceleration, and that's basically calculated from the force divided by the mass, right? So it's player thrust force divided by player mass, right? So now we can play with either of these two and see what happens, right? So then this would be in Newton, right? And then this would be in that would be speed per second, right? meters per second, something like that. So Newton, like this is where physics comes in. So you have to look at what's in Newton, right? So Newton, what's in Newton, and you'll see that in Newton is actually a Newton is meters. So that's meters per squared. It's acceleration, and so and since it's m, Newton is m times a, that would be kilograms times meters per square second, right? So that would be then meters per square second. And we just put that in here just for fun, to kind of remind ourselves like what's actually the physics here that we're actually looking at. Okay, so now we got the player thrust acceleration, and that's basically, but that's our direction. So what we need to do is we need to actually apply that to our player, but in the direction that it's moving, right? So so basically the thrust, right, is, so wherever we rotate, right, if we apply thrust, we always apply it in this direction. So if we apply that, we apply it in this direction. So we need to actually take that into account when we apply it. So, and since I already did that, I'm going to make sure that we're doing this correctly. So what we actually need to do is, okay, we go back to the player, equals velocity, right? So we have the velocity, and then we have the acceleration is given. So then we need to calculate the acceleration on x is basically the cosine of the, so we need the angle of the player actually, right? So we need the angle of the player. It's basically the cosine of the angle. That's the factor of x, and then the factor y is the sine of the angle. And then the velocity basically would be the velocity that we have, and then we apply the so then the delta of the acceleration, right, will be the game prop. So that's what we actually pass in here. We're gonna say final double thrust vector. Let's just say keyboard, but the thrust will be the same for keyboard and for gesture. So we can just do that. Make that required. This dot thrust vector. All right, and now we can basically apply this here. So we can say dA equals the it's a thrust vector, right? Okay, and then all we have to do is do AXA times dA and then YA times dA. And now we're basically applying the velocity because we calculated the magnitude for each axis, right? So basically we're saying, okay, we want to increase the velocity, but let's say I don't know how to use this thing. Apparently, let's just do it here. So if the player, right, is it being pointing, if it's pointing this way, right, exactly like here, then the sine of that angle, which is 0, will be 0, and the cosine will be 1, right? So then all the force will apply in this direction, and anywhere in between, sine and cosine will basically be, kind of a fraction of between 0 and 1. So they each get a certain percentage of the thrust, right? And actually, we can probably inline this. And so basically, then we know how to increase the velocity in the right direction. Okay, so then we basically say model dot velocity equals increased velocity, right? velocity, and we give it the current velocity, and we give it the angle of the player. And you can see that we fixed the angle beforehand. So if there was a rotation and a thrust at the same time, which is very unlikely, we would accelerate in just the last, into the direction of the last rotation. Okay, so that's so basically now we are increasing the velocity, but we are not applying the velocity yet, right? So now actually what we need to do is but the thing is that the player is moving still from the previous thrust and before the rotation. So what actually needs to happen is the top position, right? We need to actually apply the velocity that the player currently has to the player to move it. So so let's think about how we can do that. And then I'm looking through here. I'm just going to show. I'm looking through some code that I already have to make sure that I'm not going to get ourselves confused. So basically, there was something with player movement. Here we go. So okay, so basically here we have something like this. So we're gonna take that code. So basically what we're doing here, we are first producing the player world position and then adding the velocity that we have to it. And then we can always get back to the top position of the player. I'm not sure if this is like the best way, but basically this takes care. So basically like if this is actually an easier way to do this, because if we were to like say take the top position and maybe apply, so let's just look at the top position again. Top position, right? So the top position is a mixture of the column and row where the player is, which is this square, and then it's the relative x and the relative y inside that square, right? The player might have moved up a little bit, right? So then y would be like greater than 0. Well, if we now try to say, okay, well, let's apply the velocity to relative x and relative y, then we might actually move out of the tile, and then we have to do all this logic to figure out that, okay, we actually now need to increase the row and make the relative y negative because we're just basically down here now. It's much easier if we just first convert it to world position and then go ahead and apply the velocity, right? And then we can always go back to the top position from that. So what we'll do is, so we want to get a top position out, right? And so we're going to say apply movement or move. Let's just say move. And what we'll actually need is the player model. We need what we need is actually the current position and the speed. So actually it's not double at all. It's basically the current position, which is the tile position, and the velocity that the player has, right? And you can see I'm not passing the entire model. I could just always pass the entire model in here, but maybe we'll use these. What is it complaining about now? What? No way. I don't understand why. Oh, I mean the vector. Because we might want to reuse this code somewhere else, and so maybe we want to move something else as well, right? So so what we'll do, first of all, we get the world position of this, and so basically we say top position, and I'm tired of typing world position from, so we just assume this exists, and then we'll basically create it. So we create this method. Okay, and it spits out the world position, and I know we're going to have the reason why I didn't have it originally, because now we have circular reference, but I hope this will be fine. This here, and now we're going to say world position dot from top position, which is this, and then return that, right? And since this is so small, let me do this. Okay, fine. So now we got to world position, and then what we'll do, we'll apply the velocity to it, right? So return we p dot translate. Okay, so we have it to offset. But what we also can do, we say final updated or whatever, or new world position equals the world position of this thing dot x plus the velocity dot x, and this one dot y, and it doesn't have that. Let's see, plus velocity dot y, and it's complaining for some reason because this one have d. So now we have a world position that has the velocity applied, and then we just return the to top position of that. So now this should be happy. So now basically what we can do, we can say the model, and we said we want to apply this up here actually, model dot top position, right, equals increase move, right, and we get to give the current top position and the model at velocity. Okay, now this one needs to be non-final for now. Okay, so what's the complaining about now? I have no idea what happened here. All right. Now we actually can say if the velocity is actually 0, we don't have to do anything. So if velocity equals vector dot 0, and this should be existing, so nothing will change. So what I understand, it's because it's on the offset. So basically what we could do, we could create, let's just do that to be nice. We're going to create a little, just a little thing that forwards to the offset 0. So so we create vector 0, and it's going to be a getter, and it's basically just returns offset dot 0. And let's see, maybe I have I keep getting the order of things wrong. Okay, this belongs down here. Okay, so now we got that, and now all we need to do is so player model, meet the velocity. So the velocity at first will be vector dot 0, right, when we start out, and then here we need the thrust factor, which will be the thrust factor of whatever our game props say, be a thrust force. Okay, so maybe just should call it also thrust factor. Oh no, actually let's change this one because it's not really a factor force. All right, cool. So now actually what should happen is now when we render, we should actually get the player already moving. So let's actually see if that works. Let's go over here, save. We get a bunch of problems. Is not a subtype vector. Okay, so that's annoying. So, but I mean, it's very easy to fix. We just say vector 0, 0. And then it can also be and probably it can't probably be cons, but that's fine. So okay, we have that. Now it's still complaining. No, actually, it's still complaining from before. So what? Okay, now it's not complaining anymore. Okay, so now we can still rotate, move forward and back, forward. Nothing happened. Okay. So let's look why that's going on. We have the player, and we're saying if it contains key up, we want to move, right? Increase velocity. So, oh, but what we don't do, or we do move, okay. We actually do move. So something is not working. Let's look at the keyboard. If it's arrow up, we return game key up. So that's it. So what we'll do, we put a little in our player, we put a little debug in there and say debug print. Well, actually, let's put it here first, the increase velocity, right? So we want to show that we're actually hitting this, increasing velocity, right? So if you push up, okay. So we keep getting these little fun type issues. So it looks like translate here returns an offset. So that's just ugly. So that's why when we actually return it, we're getting an offset back instead of a vector. So we would have to override all these functions to return offsets instead. And right now we have no gain from that. So what we'll do instead, we'll change all the vectors to offsets for now. We'll worry about this later. Vector offset. Yes. Okay. Then in the player model, yes. Okay, so we get offsets now. Undefined class offset. Okay, we need to import it. And actually, I want to show. So we get that. Now with the vector, we just remove all this. And so now we should get errors wherever we didn't fix this yet. So we want to actually offset 0 here. Import. Again, we want to show, don't get confused with the material thing. Okay, so now we should actually be fine. Okay, so we did move. Okay, we increased, but we flew out of area. So basically our acceleration, first of all, we increased multiple times. You can see that we increased the offset multiple times for one key press. 1, 2, 3, 4, 5, 6, 7. So it seems like we need to slow things down a little bit there. But what we also could do, so first of all, like we only want to apply the thrust once. So we'll see like what we can do about that. But for now, what we could do is in the game props, we just we decrease the force slightly. Let's see what happens now. Okay, we're still very fast. Okay, but now let's decrease the force even further. Okay, and now we can actually, oops, and then we moved over there really fast. So, but we did fly into the right directions and stuff like that. So this is the, or maybe we have a totally wrong mass here. So let's do that. Let's do. Okay, so we can move. We can spin our player. Okay, that's better. Now we can actually move our player, and we can see that somehow we're still getting multiple. Every time we apply it, we get multiple velocities applied to it, but that's fine. We may have to have a different thrust force for the keyboard versus the gestures, but we're going to get to gestures in a little bit. So for now, that is actually fine. Okay, so we're actually happy about this. This works really nicely. But we're going to keep that log there to remind ourselves that we are getting so many keystrokes. So the idea was that, you know, you fire thrust. It's not like every time when you hold down the key, you would fire thrust multiple times, which is actually fine. But the thing is, every time we fire thrust, we get a little faster. I mean, that's actually fine. So that's actually not bad. So basically now we can actually move the player around. The speed is being applied. Well, what I'm worried about is like that we're going to get the thrust firing multiple times. Basically, what you have here, we have a thrust thing going on. I'm not a huge fan that but the reason why this is because the game loop was so fast that basically we're getting per key press, we're getting like the keys pressed 4 times. Which is probably fine because we do this, we also apply multiple thrusts. So that's fine. So basically what we just need to do is we just need to change this a little bit to say that this is actually the keyboard keyboard player thrust force. Right, and then we have another one for gestures. So that also means that wherever we use this, we want to rename this keyboard. Okay, now we got that. Now let's make sure everything still works. Okay, all right. Okay, now we can move the player. Cool. That's a good point to stop. We're almost at the top of the hour. I want to continue at the top of the hour. So what I actually do is I'll make sure that this also works in the browser. Okay, it works nice. Okay. So we got this game now working in the browser and on Mac, and obviously it also works on in the phones. That's not. I'm not concerned about that. More concerned about the other things. Okay, so what we'll do is we'll check this in. And what I'll do is we're going to do a Flutter Build. I think maybe you have to say web. So we'll publish the latest version. So the our web page version is up to date. All right. And so basically what we'll do, we copy everything that's in web to our GitHub pages. So I have a directory where the GitHub pages branch is always checked out. So I don't have to go back and forth between branches here just to publish this. So that's not cool. Why did nothing change? Oh, it's in build. Okay, yeah. I did that mistake before. So basically, actually what we need to copy is build web to our GitHub pages branch here, but to for GitHub. Okay. Now if you go there, should have some changes. Okay, cool. And then Chrome. Okay, so we put that up there. Now we're gonna go back to our main one and we're gonna tag this. So we have already some tags. Get tag, and this is basically episode 06. And I'm making it, and the end will obviously in this case be the same as the next episode start, but in case I decide, you know, in between episodes to change something so people don't get confused, I'll tag it. And in some cases there will be the same 2 tags for the same thing. Okay, so now actually what we should be able to do, just to double check that this got published correctly, we should be able to go here and we should have a moving player. Okay, so it may take a while. Okay, so now, okay, cool. Now I can actually fly around, and that's good. So I'm going to take a 10-minute break. I'll be back at the top of the hour.